Hi everyone, today I'm going to be proving book problem 9.4b, which states, let s sub 1 equal 1, and for n greater than or equal to 1, let s sub n plus 1 equal the square root of s sub n plus 1. Assume that this converges and prove that the limit is 1/2 times 1 plus the square root of 5. In order to prove this, we want to let s sub 1 equal 1 and let s sub n plus 1 equal the square root of s sub n plus 1 for n greater than or equal to 1. We want to assume that the sequence s sub n converges. We now want to suppose that the limit s sub n equals s. Because we let s sub n plus 1 equal the square root of s sub n plus 1, we can say that the limit of s sub n plus 1 equals the limit of the square root of s sub n plus 1. We now have that s equals the square root of s plus 1. By squaring each side, we get that s squared equals s plus 1. We can put this equal to 0 and get that s squared minus s minus 1 equals 0. We can use the quadratic formulas to solve for s. By plugging in the appropriate values, we get that s equals 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And with further simplification, we get that s equals 1/2 times 1 plus or minus the square root of 5. So we now have that s equals 1/2 times 1 plus or minus the square root of 5, which implies that the limit of s sub n equals s, which equals 1/2 times 1 plus the square root of 5. Thus, the limit of s sub n equals 1/2 times 1 plus square root of 5. Thank you for watching.